So what we're continuing with today is the stuff we did yesterday, talking about lines, rays, line segments, rays, opposite rays, all of these different types of geometric features. So we finished off with line segments, rays, and opposite rays. So a line segment differs from a line because it has what? Two endpoints. Because if it's a line segment because it has two endpoints, two places it stops. A ray is a line that has one endpoint and continues on forever in the opposite direction. Opposite rays are two rays that go what? In opposite directions and makes a line. And so that's what we're going to be doing today, is naming some of these here. So our first one we're going to look at is, there we go. We want to give another name for line segment GH. HG. So HG. And then above it we would put, so just like this here, yes? Not quite. What's wrong with that? There should not be arrows. I'll do that every now and then. Because again, we shouldn't have arrows. So the line segment, the ray above it, is going to kind of match what it is. Since this is a line segment, we have a line segment above it. If it was a line, we would have a line above it. If it's a ray, we will have a ray above it. Okay. Now there's no other way to name line segment HG because there's only two. It's either GH or HG. Could we use J, point J, to name line segment HG or GH? Is HJ, is this segment here the same as HG? No. They have a different what? Length, right? So they're two different segments. So that's different from lines, because lines, since they extend forever, we could use HJ to name the line, because it extends out all the way through those points, yes? Line segments don't, so they are different, okay? Now let's look at the next part, rays. Name all rays with endpoint J. So what would we want? Well, we can have J, E. Now we're going to have a ray above it. So I'm going to just draw the line first. I'm not going to put the arrow because we're going to need one arrow. Would the arrow go above the end of that line on E or on J? So would we have the arrow on this side, over here, or that side? It would be on this side here, the side next to the E. Now the way we do this here is we really, mathematically speaking, the way that they kind of do things, they want it so that the arrow is always pointing this direction. This way is not technically wrong, we just don't do it this way. Okay? Because this way is not technically wrong, it's an awkward way to do it. Okay? Does that kind of make sense? It's almost the equivalent of if we're ever going to go shake hands, but because of COVID we can't do it. Because what do we normally do? If I put my right hand out, you put your right hand out. If you came up to shake my hand, you put your right hand out, I shook with my left. That'd be awkward, wouldn't it? That's the same thing. I mean, you're still shaking hands. That process isn't changed. It's just awkward. That's what this is. Because it's still telling us it's going from J through E and going on. It's a ray, starts at J, goes through E. This is a ray that starts at J and goes through E. It's the same thing, but it's a little weird, isn't it? So it's not wrong. We just normally do it this way. Does that make sense? And the arrow is always going to be on the side of the point that it's going through. Because it's starting at J and going through E. Now another one would be what? J, G. You have J, H. And last but not least, we have J, F. We have 4 of them. Because when these two lines intersect, they make 4 different rays. Now, the other part of that question was asking name 2 pairs of opposite rays. So opposite rays do what? They go in opposite directions. So I'm going to just pick JE since we did that one first. What is the opposite ray with JE? JF, because it's going in the opposite direction. So that leaves us with JG and JH. And those are the pairs of opposite rays because they're going in opposite directions. Questions on this here? If I keep standing in the way, just tell me to move. So any questions on either one of these here? We good to move to the next slide? Yes? I feel like there's a few still copying. Yes? Okay. So are we understanding everything so far? Yes? It's all about terminology and how we write it. And the more that you get this terminology down and understanding how to use it, it's going to make this easy. Because if we can utilize these terms and how they work, together we can start solving some things. We need to see another way to name a line, ray, or 2 opposite rays. You all feel pretty comfortable with this, what we just did? Okay. If that's the case, we're going to move on to this here. And again, I will reiterate this. If something doesn't make sense, ask. I do not mind doing more examples. I put them on here for a reason. Even if we need more than that, I will do more than that. Intersection. What is an intersection? It crosses. Or 2 or more geometric figures intersect. Figures intersect. When they have 1 or more points in common, they cross each other. When 2 roads cross, they cross at an intersection. They call it an intersection. It's where they cross. It's where they meet. It's where they come into contact. So for these 2 lines here, their intersection is at where? At point A. They intersect at point A. The 2 planes intersect at line Q. So that's why they say 1 or more points. For these 2 planes, how many points do they intersect at? 2, 3. That's a whole line. How many points make up a line? Well, we need 2 to make a line, because through any 2 points we make a line. But along that line, I can have an infinite number of points. As many numbers as there are on the number line, I can make in a line. So that's why they say 1 or more points in common, because every point on that line is in common with those 2 planes. Now, when it's 2 lines that intersect, they intersect at a point. Questions on intersections? Okay. I'm going to have y'all try this on your paper, and we'll do it together here in a second. I want you to sketch a plane and a line that is in the plane. If you're thinking, it can't be that easy, it probably is. So give this a try. Sketch a plane and a line that is in the plane. Almost. Just a little much. Almost, yep. That's pretty much it. You're just missing one little thing. Seeing some that are right, I'm going to put some of you out of your torture because this is probably torturing you, yes? So what did we say a plane was?
It's a figure that looks like a
That, yes? And what did it say? Okay, sketch a plane. We did that, yes? And a line that is in the plane. So a line is what? Just a line with two arrows, yes? You think there's something more to it?
Can't you extend it extend it to...
Well, did it ask us to name it? Well, no. It just had a line, right?
Yeah.
That's a line. That is a plane. We are done. Because, I mean, we could add 2 points in here on the line to name it. We could name the plane. But if it didn't ask me to name it or name the line, I'm not going to name it. If it just told me to sketch a plane and a line in the plane. Not too bad? Was this simpler than what you thought the answer was going to be? For some, yeah. Let's look at another one. Sketch a plane in a line that doesn't intersect the plane. So if it doesn't intersect, it doesn't what? Cross it. Have any points in common? Give this one a try. Yep, that's it. Not quite. Yes. 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 Almost. Yep. Yep, that's it. Yep. 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 Nope. Wait. No, that's not.
No.
The other side.
I was looking up that one.
Almost. Yes. 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 Because we need a plane. It could be over here. It can be over here. It can be over here. It can be down here. Where's the only place this line cannot be? Inside the plane. Because even though we might say, well, the plane extends indefinitely, as long as I've drawn it where it's not inside this plane, we're saying that it's not. Because the only way we can say it's inside it or touching it if we draw it through it. Actually show it intersecting. Well, hey, that's the next one, isn't it? Sketch a plane in a line that intersects the plane at a point. At a point. I feel most of you have already got one part of this. We need a plane. And we need to draw a line that intersects at a point. You have the right idea. So there's a crate, because I see some that are doing, almost got it. Something like this here. One of the things we can do in geometry, I'm just going to make a point. Now, this little dashes, how many have seen this in a figure? When they show three-dimensional figures, they'll do the little dash. What that is saying, and the reason they do that, is it's saying this part of the line is there, it exists, we just can't see it. Here we go. and get this strap. Can y'all see the pistol that I'm holding right here? You can see the shadow, but we can't actually see it, right? We know it's there, yes? We've learned object permanence. So this part of the line that we dashed, we're saying it's still there, we just can't see it through the solid object. And that's it. All we got to do this. Questions on this here? We good with this? Let's see what's next. And I think this is the last type of problem we have, yes? Yeah, one after this, but same type. The diagram shows a molecule of sulfur hexafluoride, the most potent greenhouse gas in the world. Name two different planes that contain line R. So, this line here. So when we're naming a plane, how do we name a plane? So, right, if we had a plane, we could name it by one of the corners, but we could also name it by what? Three points that are not on the same line. We need not three non-collinear points. So there are three different planes here. I'll name one of them to start with. Because if we look at this here, well, a flat plane, yes? Would be one that we can do. So I could do G, B, so we can say plane, G, B, D. Is that flat? That flat plane would contain that line, yes? What would be another one? Yes. F, B, D? F, E, D, yes. That would be another one. And then we could do C, B, D, C, F, A. Any of these combinations of the three, as long as they're not on the same line. So C, B, A would not work. B, D, F would not work. E, B, G would not work. Because they're all on the same line. So we can almost use these three here, these three. I mean, we could use any of those combinations of three. Questions on naming that line? Get ready for the last one. Number 8. So name two different planes that contain line S. So line S, it's kind of hard to see because of that thing there. But it's this line going straight up and down. Plane G, H, L. Because GHI would give us that straight line. So we can't use it because there are three collinear points. They're all on the same line. So we have to use something off of that. J, yes. I heard something with an I. J, H, I. So that would be the same, but we could do, say, H, I, K. Because those are actually three different planes that are all intersecting there. Can y'all kind of visually see that there are three planes we can make up with that? So do we have these down? Yes? Okay. Number 9. Name 3 different planes that contain point A. Well, point K. Say what? KHJ. So we have KHG, yes. KHL, that flat one. KHJ, that flat one. How about this one? Probably stretch your mind a little bit. KGL. Because through any 3 points, you can make a plane. I'm going to draw kind of a triangle, but it's essentially slanted. It's a flat, slanted plane. Because we never said that a plane had to be straight up and down or flat. It could be at any angle. Kind of like the roof of a house is slanted. That's essentially what we have here. KHL? KHI? Yeah, that would work. That'd be another one. Because as long as we have 3 points and they're not on the same line, we can make a plane. We can create a plane. Any questions on this here? Are we ready for the last one? Yes? I'm good to erase this here. Last one, number 10. So we want a plane that contains ray HJ. HJI, yes. HJK. HJG would work as well. We could also, I think, use HKL if we wanted to, because HJL is that flat plane, and it would extend out to J. That'd be the only one I think we can use without using J as one of the letters. Because any of the other planes, we need J in there and H, so it includes it. Does that make sense? Because if I tried GJL, I wouldn't include point H. Y'all see that there? Because if I tried to make one, here, it would be easier if I draw it. Coming out here, that triangle, does it include point H? No, because point H is over here and the plane's over here. So the only one that we could really do would be HKL, would be the only one that we can use and not include point J. Any questions on this here? Hopefully not too bad so far. So that is the end of the lesson.